Good day, girls. In the third unit of your integral calculus and in the fourth unit, you are going to talk about multiple integrals, and specifically we have to talk about double integrals and triple integral, that is in unit 3 and unit 4 respectively. So in the third unit, you have, along with double integrals, which we are going to deal with Cartesian as well as polar coordinates. And then we are going to also discuss about how to change the order of integration. Okay, and you all you're all familiar with the single integral, that is integrating a function with respect to single variable. So now using this, we are going to evaluate double and triple integral. So if you are thorough with the single integral, then evaluation of these two are not difficult, because single integral is the building block of double and triple integral. So now before we actually go into the evaluation of double integral, we shall just recollect the concepts what you have learnt in +1 or +2. Given x-axis and y-axis, how to plot a point P of xy. You all know that any point P of xy is plotted like this. You have the x distance to be Pm and y distance to be Pn. So this is how you plot any point in the coordinate axis in 2D. Okay. This point is the origin, which is denoted by ordered pair. You have to use only this ordinary bracket 0, 0. Okay. Then equation of lines, what we come across in this chapter is x-axis, whose equation is y is equal to 0. Whenever we have x-axis, y will be absent. So the equation of this line, x-axis is a line, so whose equation is given by y is equal to 0, and y-axis is given by the equation x is equal to 0. And any line passing through the origin, okay, which makes some angle with the x-axis, is given by y is equal to mx. Line through origin making some angle is given by y is equal to mx. M denotes the slope. Suppose theta is the angle made by this line with the positive direction of x-axis, then m stands for tan theta. Now, how do we write the lines parallel to x-axis and y-axis? See, we know that the equation of x-axis is given by y is equal to 0. So any line parallel to this x-axis, any line parallel to x-axis will be given by y is equal to constant. So suppose, for example, I have this line to be at 2 unit distance, then it is given by y is equal to 2, and in the negative direction it is given by y is equal to -2. And in the same way, for x is equal to 0, which is y-axis, we have any line parallel to that. See, we know that the equation of y-axis is x is equal to 0. Any line parallel to that should be of the form x is equal to a constant. So suppose I have this to be at 3 units distance, then the equation of this line will be x equal to 3, and in the negative direction x is equal to -3. So x-axis equation y is equal to 0, and y-axis equation is given by x is equal to 0. Any line making some angle with the positive direction of x-axis, y is equal to mx, and the lines parallel to x-axis means y is equal to constant, and parallel to y-axis means x equal to constant. And one more thing what we need to notice is, along x-axis and any line parallel to x-axis, x alone varies. So in this on this line you have only x varying. You can write any point on this as 1, 0, 2, 0, 3, 0. So in which the y coordinate remains as such, only x varies. So along x-axis and any line parallel to x-axis, x alone varies. So in this line also x alone varies. So along x-axis and any line parallel to x-axis, x alone varies. and along y-axis and any line parallel to y-axis, y alone varies. So in this you will represent any point as 0, 1, 0, 2, 0, 3, and here this way 0, -1, 0, -2, and so on. So you have only y varying along y-axis and any line parallel to that. So on this line also y alone varies. So remember this statement: along x-axis and any line parallel to x-axis, x alone varies, and along y-axis and any line parallel to y-axis, y alone varies. So now suppose we are given a rectangular region. So these are individually we know the equation of the lines, and in the previous slide we had. Now if I am given a region like this, so I am given a rectangle, and if we have just the lines y is equal to 0, y is equal to b, x is equal to 0, x is equal to b, it represents a line. But if I want to consider rectangular region, that is the portion inside the rectangle also, so in that case we have a region. So in that case, how we can cover the region? So here comes your double integral. When you have a double integral, it is somewhat similar to your partial differentiation. When you are given a function of both x and y, when you have to differentiate partially, you will, with respect to x, you will treat your y constant and differentiate with respect to x. And then if you want to differentiate with respect to y, you will treat x as a constant. So in the same way here also, if I have to integrate with respect to, see, this is called integrand, this is called integrand, these are called limits, and this is variable of integration. So in an expression like this, you must know what to each one represent. So this one is called integrand, and this is called x and y. They are called variables of integration. And this limit, see, first we have x, so the limit for x 0 to a, limit for x 0 to a, and limit for y 0 to b. So these are called the limits, integrand, variables of integration. So in this case, first you integrate with respect to x, substitute the limits, you will treat your y constant, and then integrate with respect to y, because x will not be there, you have substituted the limits, and then integrate with respect to y, substitute the limits. If the limits are not given, if you do not know the limits, you will have the resultant to be in terms of x and y. That is, you will integrate, suppose I am given, say, x plus y. This one is, say, x plus y. Then when you integrate that with respect to x, you will get x square by 2 plus xy. And then you will integrate with respect to y, so that you will have x square y by 2 plus, here already y was there. So when you integrated with respect to x, xy was there. So now when you integrate with respect to y, you will get xy square by 2. So that is without the limits. If you have with the limits, when we do problems, each one will be very clear. So it is only the outline that how we evaluate the double integral if we are given a region. So only for that we are having all this. So how without limits, how to integrate double integral, and how when limits are given, how to integrate, and when region is mentioned like this, you consider a rectangular region given by the equations like this, how to obtain the limits, and then in various cases also how to obtain the limits. So that is what is covered in this video. So you have so when you have rectangular region, how do we give the limits? See, when we consider this, we have if we want to cover the entire region, so what we do is we consider first lines parallel to x-axis, y-axis, because parallel to y-axis means the equation is given by x is equal to 0. So in this, y alone varies. It varies from what to what? You have y varying from 0 to. So this is, here I will have y is equal to 0. then as it goes you will have y is equal to 0 to b. But remember that we want to cover the entire region. Same is the case with any line, anywhere you can start. So when you want to cover, see, first I am covering one single line, and then to cover the entire region we have to give the limit for y, which varies from x, which varies from 0. Here x alone varies. Any line parallel to this is on the x-axis it moves, so that means x alone should vary. So you have to give the limit for x. Now as for rectangular region is concerned, the limits being independent of the variables, they depend only on the constant y is equal to 0 to b, x is equal to 0 to x is equal to a. They depend only on the constants. So the order in which you integrate is immaterial. What is the meaning of it? See, whether I integrate with respect to x first, give the limits for x, and then integrate with respect to y, give the limits for y, or the other way around. Integrate with respect to y, give the corresponding limits of y, and then with respect to x, give the corresponding limits. The order in which they are integrated doesn't matter. The reason is, see here, how the same region can be covered. We can go through the limit concept in this way also. That is, suppose I draw lines parallel to x-axis, say. Then in this case, first my x will vary from 0 to a. In this case, my x will vary from 0 to a. I have to cover this line. So my x will range from 0 to a. So it goes like this. It is 0 here, and it has to cover the entire line. So which means x is equal to 0 to a. And in order to cover the entire region, I have to move this on this y-axis. So along y-axis and any line parallel to y-axis, y alone varies. So I will give the limit as. So according to this integral, the region is covered by drawing lines parallel to x-axis. According to this, had we written y and then x means what I what I showed earlier. So that will be the case. So in this case, according to this, it is you have to draw lines parallel to x-axis, that is y is equal to 0, and then you have to cover the entire region. And when you cover the region, you will have to remember that from the lower line to the upper one that you have to go. From the bottom to top you are supposed to go. And in this case, if you are covering the region like this, then from left to right you have to cover the region. From left to right, when you are covering the region by drawing lines parallel to y-axis. When you are drawing lines parallel to x-axis, from bottom to top you have to cover. So what is the initial point in this? In this case, the initial point lies on this line. The end point lies on this. And in this case, when it moves like this, you have to give the limit for, it varies parallel to y-axis, y alone varies. You have to give the limit for y. Okay, y is equal to 0 to b. And when you want to cover the single line, you will have to give the limit for x. X has to range from 0 to a. And to cover the entire thing, you have to go like this. So for which your y should alone vary, because it's a line moving parallel by considering, even though it is parallel to x-axis, but where are the points? The points are on the y-axis. So y alone varies. So you have like this. So you have to give the limits for y as 0 to b and x is 0 to a. So how the region is covered, that should be known, because when we want to change the order of integration, however it is given in the problem, we have to convert that. See, when you draw lines parallel to x-axis, and then you're covering the region means when you're covering the region like this by drawing lines parallel to this is y-axis, then it goes under type 1. This is for reference, we shall call such types of integration as type 1. And in the case of type 2, we are drawing lines, that is, you are covering the region by drawing lines parallel to x-axis. So x-axis ke parallel nee cover panna abdina, we shall call it as type 2 along x-axis, and any line parallel to x-axis, x alone varies, and here along y-axis and any line parallel to y-axis, y alone varies. So this one we shall call as, okay, this one is type 1 and this one is type 2. So changing the order of integration is, you may be given the given integral to be of type 2. In that case, you will have to change it as type 1, or you may be given type 1 and you will have to change in terms of type 2. So that is what we mean by changing the order of integration. First with respect to x, and then with respect to y, or with respect to y first and then with respect to x. That when the problem comes, it is again how the region are covered, only that is dealt in this video. So we are only telling how what is the meaning of this equation x equal to 0, x equal to a, y equal to 0, y equal to b, and when I consider them, all of them together, individually you know them to be lines, y-axis parallel to y-axis, x-axis parallel to x-axis, individually you know them. But when you are given all of them together like this, what do they represent? They represent the rectangle actually, and when region comes, this is how we express it. I mean, how we integrate that, the limits, how they are given. So that is what is explained now. Okay, the same is the case when you are given a square. This actually represents the equation, the square only. The region when I am given, this is only square. So y is equal to 0 to y is equal to a, x is equal to 0 to x is equal to a. See here again, when you are talking about the limits, then this is how you have to discuss. You will have to first integrate with respect to x or y. That's immaterial because the limits, they are independent. The limits, they are independent, so there is no problem. And to cover one line, we'll have to give the limits. So this is we have y is equal to 0, and slowly it goes to the upper line. So that means 0 to a, y varies from, because it's a line from here y is equal to 0 to y is equal to a, it goes, and this is the lower, I mean the initial point, this one, and this is the end point. It lies on the x-axis, so x should vary. For this, x should vary from this to 0 to a. So not to cover the entire region, it has to move like this. But to cover single line, what we need to do? So we have like this. So it is similar to that of your square region. So next we'll concentrate on triangular region. So in this case, if I am given such an equation, then how do we draw the diagram? So this is x equal to 0 is this line, and y is equal to 0 is this line, and x by a plus y by b equal to 1. It makes intercepts a and b. So this point is 0 comma b. This point is this point is 0 comma b. So you have that is because your equation of the line is given like that, x by a. It makes, and this is called the intercept form of equation of a line. intercept form of equation of a line. So A stands for x-intercept and B stands for y-intercept. So that means these points are given by this is 0, 0. So that is origin. So you have this point to be origin, that is 0, 0, and this is a, 0 on the x-axis. X should vary, y should be 0, and on y-axis y should vary, x should remain 0, and this is the line x by a plus y by b equal to 1. So in this case, how are we going to see? In the previous case we had the limits to be constant. It need not be the case always. So as in this case, when we want to cover one single line, see, we want to cover this. If I want to cover the entire region, as such this represents only a triangle, outer one. So only that it represents. But when we want to have the region, triangular region, then how are we going to cover the region? How the limits are given? So that is what we are going to see. Now we have, when I start with this, I will have y is equal to 0. Then it goes up, and the end point, initial point is a point on y is equal to 0, and here this is a point on this line. So on this line, what is my y? You can take x by a to the other side, so 1 minus x by a. This b can be cross multiplied, so you have b into 1 minus x by a. So my upper limit for this y will be 0 to b into 1 minus x by a. And how about the limit for x? So you have ranged only y. Now you'll have to cover the entire region. So the entire region is to be covered. So that means I have to give the limit for x. It should range from 0 to a. It should range from 0 to a. So because it moves on the x-axis. And remember, don't think that this line goes like this, so these regions will be covered. No. So that this is the guarding line. இந்த இது வந்து உங்களை அந்த பக்கம் போக விடாம இதுதான் பாதுகாக்குது. ஸோ அதனால அதுக்காக தான் இந்த இடத்துல y is equal to 0 to b into 1 minus x by a. So this line will not go beyond that. So when you range your x from 0 to a, it will go like this only, but remember that this is already guarded by this one, y is equal to b into 1 minus x by a, that is the upper limit. So it is not like the previous one. So here your y depends on x. Your y depends on x. So in this case, as you wish, you cannot integrate. Here we said that as you wish, you can interchange. Whereas here you cannot say as we wish we can interchange. So in this case, double integral, you cannot have it like this. You will have to integrate first with respect to y and give the limits for y only. So here it will be the upper limit. So here you will have so you can have this. I actually removed. That will be your here. It should be here. It should be. So your this limit is for your y. So this limit is for your y. So you'll have to integrate first with respect to y, and then so this y is equal to 0 to this is y is equal to b into this. So first you will have to integrate with respect to y and then with respect to x. So first with respect to y and then only with respect to, in this case, because your y depends on x. So then for x, what should be the limit? It should range from 0 to a. So let me repeat it again. So in this case, first you are given only triangle with this line. X equal to 0 means y axis, y equal to 0 means x axis. So all that you have got already. But here another equation is given which represents the equation of a line. It's not a line parallel to x-axis or y-axis, or it's not a line through the origin. So it is in the intercept form. It makes intercepts A and B. So you have these points as A0 and 0B. And how we cover the region. Repeatedly I am saying that this is dealt only, this video is dealing only how to cover the region, limits, how to give the limits. So in this case, when you are asked to integrate over this region, this is the region under consideration. So how do we cover it? So y is equal to 0 to y is equal to b into 1 minus x by a. So that is how the limits for this is given. When you are giving limits for y, you will have to integrate only with respect to y. You cannot give limits for y and integrate with respect to x. Here whatever limit that you are giving with respect to y means here you integrate with respect to y. And then after getting this, you will have, after integrating this with respect to y, the resultant will be in terms of x only. So then you can integrate with respect to x. So this one with respect to x, and you have to give the limits for x. So that here from this diagram you can see that. So when you have to evaluate double integral without drawing the diagram evaluation, and especially in the case of changing the order of integration, if the diagram is not drawn properly, then you cannot do the changing the order of integration. And remember that this will come in the case of vector analysis also. So you have to be thorough with the concept here itself. Only then you will find there the problems to be very simple. So next is the circular region. So in that case, if you are just given x square plus y square is equal to a square, you know that this represents a circle with center at the origin and radius is a. This is the radius is a. That's very obvious. Now when you see, as for problems in circle is concerned, you can either go by Cartesian form or polar coordinates. So that we are going to deal next, how we can change over from Cartesian to polar. So here again, if I am given, if I am considering only circle means points on the circle, and but here we are going to consider circular region. So region means inside the circle also we have to consider. So in this case, how we are going to give the limits. So here x square plus y square is equal to a square, therefore y square is equal to a square minus x square. So your y actually, when you consider y, it will be plus or minus root of a square minus x square. That minus corresponds to this point. Okay, so you are actually when you plot this, you will have to have your y. We are here giving only the y coordinate. Why? Because it's a line parallel to y-axis. How y ranges? Only for that purpose. When you represent it as a point, it should be written in terms of ordered pair only. But our job is to only get the limits. How the limits are to be determined. Only for that. Only that is discussed here. So for that purpose, only the y coordinate that is mentioned here. So minus square root of a square minus x square 2 plus root of a square minus a square minus x square. So how we determine that? You just see the initial point and the end point. So whether you are here or anywhere, you will have the initial point to be a point here and the end point to be this. So for any such thing, you will have to depend only on this equation. So minus root of a square minus x square to this. Now to cover the entire region, I have to come from here to here. So that means my x should range. My x should range from minus a to plus a. My x should range from, so you'll have to see this. Here you have minus a to plus a. So that's the limit for your x. And the limit for y is minus. So where from you are getting the limit for y, you go to the equation, the given equation from which you obtained in terms of x your y. So this is because I am covering the region by drawing lines parallel to x-axis, parallel to y-axis. The same thing could be done by drawing lines parallel to x-axis also. Like this also you can cover. So in that case, what you do is, here like this you can cover. So this point will be 0 comma a, and this will be 0 comma minus a, because radius is a. This point will be 0 comma a, and this point will be 0 comma minus a. So you will give the limit for y as it varies from here. It varies from x first, because it's a point on this, and parallel to x-axis, x alone should vary. So you'll have to give the limit for x. So in that case it will be root of a square minus y square. Instead of this, you will have that to be a square minus y square. Okay, so and here also it will be that. So and then your instead of y you will have, so this will be the limit for something happened. So you'll have to just change the roles of x and y. That is all. Simply if you have to remember, then you can. But without diagram you cannot give the limits and understand how the region is covered. So next we have the relation between the Cartesian and the polar coordinates. So here in Cartesian we had in the very first slide that p of xy, any point is plotted like this. This is your x distance, this is your x distance, and this is your y distance. And here if it makes an angle theta and this distance is r, say, then from the right angle triangle OMP you will have cos theta. Cos theta is given by OM by R, and sin theta is given by PM by R. Rx is equal to R cos theta and Y is equal to R sin theta. So this is called the initial line, and this is the pole. This is pole. This point is termed as pole, and this is initial line. This is the vectorial angle. This is the radius vector, we can call it as. And theta is the vectorial angle. Theta is the angle made by this line with the radius vector with the initial line. So this is p of r theta. In polar coordinates, the same point is represented as p of r theta. So if r theta is given, then how do we relate x and y from polar to Cartesian? Or from Cartesian to polar, if you have to go, you have to make use of this transformation. X is equal to r cos theta, y is equal to r sin theta. That comes from this. So now if we have, in the case of circle, as I said earlier, in the case of circle, we can have, see, we have the same regions, x square plus y square is equal to a square, but we want to cover it in terms of r and theta. So you can draw radial lines. See, what we did in this case was we drew lines parallel to either y-axis or x-axis, whereas in this case we can cover the region by drawing radial lines like this. We can draw the radial lines, and that can be covered. So here it goes. So you can have like this, when it moves, the entire region will be covered. Okay, the entire region will be covered. But to cover one single, for this one, if we have to cover, means r should vary. So it varies from what to what? Naturally from 0 to, because this point is the pole 0, 0, and radius is a. So r should vary from 0 to a. Yes, instead of a square, suppose I am given say 4 square, then I will say that my r ranges from 0 to 4. 0 to 4. Okay, so here we have the radius to be a, so you have 0 to a, and theta, because the entire this one to be covered, you will have to have, so it will make one full round. Okay, so that means your theta should range from 0 to pi. This is your theta. Theta has to move. So like this, it has to go like this. And so entire, if I start here, say 0 to 1 full round, it goes. So that means you will have 0 to 2 pi. So your theta should vary from it. So the same circular region can be covered by drawing lines parallel to y-axis or x-axis in the case of Cartesian coordinate system. In the case of polar coordinate system, the same thing is covered by drawing, by considering the radial lines. So this is how we give the limits. And these are certain other regions. So when we do problems, you will come across. So here I have not given actually the equation of the lines. Only such types will come to mention about it. I have given this. So here what is done? The parabola and a line is given. Parabola and a line is given. The equation of the line will be given in the problem. So how to plot the curve from the given equation, that will be explained later. And here covering the region, again limits how they are given. Only for that this is explained. You can draw lines parallel to y-axis. So here the initial point is a point on the line, and the end point is a point on the parabola. So you will have to just know right now, just know about what is what. Initial point where it lies and end point where it lies. And here it is for changing the order of integration, type 1 to type 2 we have to go. So இதிலேந்து இதுக்கு போகணும்னா நான் என்ன பண்ணணும், parallel to y-axis னு வரைஞ்சது parallel to x-axis னு வரையணும். Right. So இப்போ இதுல வந்து initial point will be point on the curve and end point. Remember when you do like this, from left to right, here bottom to top, left to right, and here bottom to top. So here it's a point on the curve. In this case the initial point is a point on the line, end was on the curve. Here on the curve and then on the line. So you are changing the order. So just how to cover the region and how to give the limits, the initial and end point. So that is alone explained here. Actually we need to know what the equation of the parabola and the line. So that will be discussed when the problems are discussed. And here we consider two parabolas. So here again changing the order of integration. You are drawing lines parallel to y-axis, and that is changed to drawing lines parallel to x-axis. So here initial point is a point on this curve, and end point is a point on this one. So here initial point is a point on this green one, and end is a point on blue. Okay, so this is how we change the order. In this case we had parabola and a line. Here two parabolas. And here also you have, this problem is very important in the sense that you have here also one parabola and a line, the same problem only, but we are changing. This is the region under consideration. This is given to be the region of integration. So in this we are drawing lines parallel to y-axis. So initial point is a point on this curve, end point is a point on the line. But when you want to change change the order of integration, when you draw the lines parallel to x-axis, you can see that from this to this, the initial point is a point on this, and end point is a point on the curve. Whereas in this region, so the same region is split as region 1 and region 2. The same region is split into, it was not the case over here or here in this case. Here, because the region there was no problem, initial point, end point, they were points on the two different curves that were given in the problem. Whereas here when you consider, here this is the region, but in this case initial point is a point on this line, x equal to 0, and end point is a point on this line. It may be say x by a plus y will be equal to 1. Whereas here the initial point is a point on x equal to 0, end point is a point on the curve. Here line and curve. So in that way, this is different from the other problems. So care is to be taken when you do a problem when it is asked. So here we give a list, a rectangular region, square region, triangular region, circular region, and then the curved region, that means two parabolas and a curve and a line. So if these are the limits, so here with the equation that is discussed here, and how we can changing the order, so that is discussed, and how we get the limits, that is explained, and the integration, how will it look like. So that is what is given in a nutshell in this chart, and this is for double integral, and in the same way we have for triple integral. So when we actually, so these problems you have to be thorough with this year, so that in the next year when you do vector analysis, verification of certain theorems, Gauss divergence theorem, Stokes theorem, and Green's theorem, you can easily follow them. So here how to give the limits. The region, a region is given with the equation like this, then how to get the limits, and how to draw the diagram, and how to change the order of integration, and correspondingly what will be the limits. Here we had the given limits, here changed limits, and how the integral, double integral from the given one to the changed one will look like. So that is what in a nutshell is given in this chart. And in the same way here we don't change it, we explain how we can do the triple integral, how the region can be covered and how it could be evaluated. So that is discussed in this. And you have, in the case of 3 dimension, x-axis, y-axis and z-axis. You have x, y and z-axis, and you have circular, we had circular region. Here cube will come, so it will involve volume. So volume integral means triple integral we'll have to discuss. Surface integral means, or region means, double integral will do. So if we have to consider volume means, we need to go for triple integral. And this is a cylinder. So all these equations, when the chapter is taken, you will know them in detail. And so we will stop with this.